Okay, so part two, we'll take a look at the wastewater treatment process. First of all, wastewater is water that has been used by people in some way, and usually goes down a drain. And that drain ultimately hooks up to large sewer pipes running under your street, and then those sewer pipes run into a main wastewater treatment plant. So literally millions of gallons come in a day with that. And well, I have to be careful. We'll find out on our tour how many gallons come in. Septic systems are another way of treating wastewater besides a wastewater treatment plant. This is the most popular method of wastewater disposal worldwide. You generally have wastewater treatment plants around cities, but if you're out somewhere in rural areas, or even myself, I'm just outside the city in the mountains, so there are no sewer pipes going up there. So my wastewater is treated with a septic tank. And basically, the water from my drains goes into a large tank that's underground, not far from my home, maybe about 10 meters away. And it's large, like 5,000 gallons or so of volume. And the water, as it's sitting in there, is being basically purified by microorganisms, bacteria. And then the water from there goes into some pipes leading away from the septic tank, away from my house, into what's called the leach field. And from there, it sort of slowly leaks out of special designed pipes into the surrounding soil, where microorganisms can further break down any contaminants that still exist, or not contaminants necessarily, but organic matter, fecal matter or organic waste from the kitchen, things like that. So we're going to focus right now, though, on wastewater treatment as it occurs in wastewater treatment plants. There's two basic parts here. Primary treatment, which is the physical removal of contaminants in settling tanks. You take the water, you let it sit in a big tank, and heavy things are going to sink to the bottom. Light things like greases and fats are going to float to the top. And then you collect it. So that's like a physical removal. The secondary step is a biological removal. Water is aerated by being stirred up, and aerobic bacteria degrade the organic pollutants. You have aerobic, meaning bacteria that use oxygen. They are, they're decomposer organisms. And you have this water that's aerated with many bubbles to make those bacteria extremely happy. So they are consuming that organic waste as fast as possible so that you can make your process happen quickly and get that water treated and out to the environment. There's another step, though, that I'll mention now called the preliminary treatment step, which is this very first step where the water runs through screens and in what's called the grit tank. And this makes solid objects and grit removed. So things like eggshells or coffee grinds or even money or other things that accidentally get either flushed down the toilet or fall down a drain or go through the wash in their washing cycle, clothes washer, that can all get filtered out here. So then that's the preliminary treatment. So then here's the primary treatment. You are letting things settle out, letting things float to the top, collecting it. Then it goes into the secondary treatment, which is your aeration basin. And then most places will send it to a secondary clarifier, so they'll repeat the same first process, but on water that's already been purified. So they're just trying to get whatever's remaining. And then it's going into a filtering and disinfection tank, where it's being filtered with coal or activated charcoal or sand. And so that's a similar process to your Brita water filter pitchers. And it's getting chlorinated. And it's getting chlorinated not so you can drink it afterwards, but so that it can be released and you can be sure that it's free of any pathogens. And in Santa Barbara, we release it to the ocean. In places that are near rivers, it gets released to rivers. There are some other steps here, which are kind of on the side, but we'll learn about them on our tour. The material, the solid material that you're collecting from the processes of clarification here, they go into something called an anaerobic digester. Anaerobic. So this is where you have a building that's sealed off. Oxygen is not really coming in or out. Inside that process, you have further decomposition. And from there, you get what's called biosolids. And those biosolids can make good fertilizer for cropland, although you have to be careful because they can still contain trace chemicals or heavy metals that from the water that as it came in from whatever industrial processes. And this also produces methane gas, and that methane gas can be used to generate electricity. So that's a great thing. And these solids that were removed during the grit process, or from the primary clarification here, some of this is also just landfilled. All right, so that's the main process. And I want to mention two other things here. This is a good time to bring up DO-SAG, dissolved oxygen SAG. This is where effluent or outgoing wastewater that still contains a high level of organic matter becomes a pollutant when discharged into rivers. We try to get rid of all that organic matter using the microorganisms in the aeration tank, but still some can make its way out. The graph below shows an oxygen SAG curve in which DO level drops due to microbial decomposition of the waste as the water flows downstream. Over time and distance, the DO level recovers. So if you take a look at this graph here, horizontal axis is distance downstream. And we have two axes or two variables here. One is organic matter, and the other one in blue is oxygen level. So before the point along the river where the water is discharged from the wastewater treatment plant, you have very low organic matter, very high oxygen. Then here comes the discharge, high organic content. I mean, hopefully not too high, but higher than normal. And as you get further away, that level of organic discharge decreases because decomposition is happening as the water is flowing downstream. And it continues, and at some point, it's going to go back to baseline, what it was coming in, or what it was before the discharge. So then we call that the clean zone. Let's take a look at the oxygen. It started off high, but then during this process of decomposition, oxygen was used up by the microorganisms. Then you pretty much have your organic matter fully decomposed. So there isn't much food left for the microorganisms. So the oxygen level begins to go back up from algae, from plants along the river, from oxygen just diffusing into through the surface of the river. Especially for a fast-flowing river, that's very beneficial for water getting into the water. I mean, oxygen getting into the water. So at some point, if you're far enough away, it's going to go back to the level it was at. And that's called the clean zone. This is the recovery zone, septic zone, and the decomposition zone. You don't really need to know the names of these zones, but you do need to know the process of what's happening here and why it's happening. Okay, so I'd like you to write a summary of the notes here. I know we covered a lot of ground, and I'll see you in class.